In today's video, I want to show you how I solved problem number 4, steal, here on the Solidity Challenges repo. Alright, so start by cloning your repo, and then open it up in your preferred editor. So I'm using VS Code. I'm looking at the README for the steal contract, and it wants us to drain all registration fees from the contract. So it's pretty straightforward, minimal instructions. And it's left up to us to figure out how to do that. So over on steal.sol, okay, so let's start from the top here. We have an enum. I'll just jump over that for a moment. A host state variable with a predefined address, and we then an entry fee with a value of 0.01 ETH. So those two look important. We have a mapping of player statuses, and then our constructor here looks to be taking in our value and ensuring that it's greater than that defined entry fee. The register function here has two guards. First one seems to be checking that the value is equal to the entry fee, okay. And the next one is ensuring that we're not in a pending state. Okay, so looks like when they register, they just set our status to pending. And then the next one, approve, and you have to, only the host can approve, and then it is taking our, ensuring that we're in pending state, and then switching it to approved. Okay, so those ones are, for the sake of this challenge, they are just decoys. So here we are down at withdraw all fees. So now if I want to withdraw all the fees, the first guard here, it's looking to see if the caller, that would be me, is the host. I'm not the host, not yet anyway, so I'm not authorized. If I was the host, it looks like it collects all the fees, so address this dot balance, it represents all the fees. And they pass that variable to a call, and they're going to send it to, I guess, whoever the caller is. So yeah, message.sender. So that will be us. And they're not calling a method. So by default, they leave that empty. You're going to have a receive function on the other end then, unless it's an EOA. But in this case, we'll have an attack contract with a receive function to handle that. But it looks like, obviously, the big thing here is I can't withdraw fees if I'm not the host. How do I become the host? Okay, well, the last little bit here I see is a receive function that, again, it's going to take in the value and ensure it's greater than the entry fee times 5 for whatever reason. That's important. But that's the guard. And if we get past that guard, you can see that the host is now going to be set to message.sender. So as long as we can trigger the receive function, pass in the proper value, we can become the host. So obviously that's our in, and then once we're the host, I'll be able to call withdrawal, and as we went through, they'll be able to send all the fees to us. So my approach here, obviously we're going to need a contract and be able to handle this. So moving over to my attack contract here, you can see, you know what, why don't I do side by side? Let's put that here and we'll talk about it side by side. Let's bring that up. Okay, those two functions are the only ones we're going to work with. All right, so back here over on my attack.sol, I have imported the steal contract. I've made an instance of that contract, and now my attack function. It's pretty basic. I had 3 steps here. Step 1, we just need to provide the required amount, because as you can see here, they want an entry fee times 5. Okay, so entry fee times 5, and then plus 1, because it needs to be greater than. So that right there, just by passing that amount, will satisfy the guard. Now that's exactly what I do. I take the amount, I make a call, I pass the amount as value over to the steal contract, and I also don't define a function signature. So I'm leaving it blank by default. It'll get picked up here by the receive function simply because I am passing value. If there's no value and I tried this call, they would need a fallback function to handle the logic. All right, so now that they've made the call, we know that we're going to become the host, and now that I am the host, at that time, I can turn around and call I can call the withdraw all fees method on the steal contract. So I can call this method here. And then the fees will be sent to us. And when the fees are sent, they're going to get picked up again here in the receive function. And that's why I have it on my attack contract. All right, so let's go through the test and get that all set up and then run it and see it in action. All right, steel.t.sol. Over here, we'll go through it from top to bottom. So I've imported my attack contract, as you can see. This, again, keep in mind all tests on this repo are provided by contributors. They're not found necessarily in production, and I guess unless stated otherwise. So if you have any questions about layouts of tests, just keep in mind there's no real standard format. It comes up to the individual. And I say that because I see that the contract is called challenge, yet the EOA is called challenger. So the language is very similar. So let's keep that in mind for a second. So at the setup here, the challenger, the EOA, is dealt 1 ether. And then they turn around and the challenger is actually going to deploy the contract. That's interesting. So they're going to deploy the contract, and the steel contract is going to start with a value of 0.02 ether. Okay. The pre-check is going to check that the balance of the contract is indeed 0.02 ether. And now the actual attack is going to happen here in the test drain pool. They have a starting balance and a registration fee. And then the challenger here is going to be registered. So they register on our behalf. So we register the challenger and we pass in the registration fee. Okay. All makes sense. And then they assert that the balance on the contract now equals the same value as the starting balance plus that new registration fee. Okay. Here's where they want our code. And you can see the code that I provided. I simply created an instance, or I deployed my contract, we should say. I deployed my attack contract and passed in a starting value of 1 ETH. And then I called attack. And then the logic that we discussed will run. And after it's all done, we simply need to pass this assertion. We need to assert that the challenge contract has a balance of 0. All right, let's move over to the terminal. I've already preloaded the command. So we'll run it, and it has passed. Here we can see going through the trace logs, again, top to bottom, obviously, register. Yeah, okay, yeah, we were registered, sure. Here's the new attack contract. So the attack contract was deployed, and we have this entry fee, and it hit receive, and then okay. So that entry fee here was the value that was passed. It got picked up by the receive function. And that's at the point where we were now the host. And as the host, we were able to turn around and call the withdraw all fees. And it sent the value to our attack contract where our receive function picked it up. And you can see the value plus that 1 ETH hanging on the end. That 1 way hanging on the end. And in the very end here, our assertion, we needed to assert that the steel contract balance is 0, and you can see that it is, hence all green lights, and we passed. All right, so that was my approach to solving the steel contract. If you guys had a different one, love to hear about it. Just drop a message in the comments. All right, see you in the next one.